Okay, welcome to my first video, and it's all about escape velocity. I'm going to work through the slides and talk about what things mean, and hopefully you can hear what I'm saying. Okay, this first slide introduced the idea that thought experiments play an important role. Without creative thinkers, we never get to the next step. We will come back to it, but I want to remind you that the PFAs, or prescribed focus areas, you may get questions asked on these, and you need to keep this in mind as the context for the knowledge. Okay. Why is that blurry? Okay, we're on to our next slide. This is outlining Newton's actual thought experiment. So, in this case, you imagine that you're standing on an unbelievably high mountain and you're launching a cannonball. We already know that the direction of movement of the cannonball would be in a parabolic arc, and that it would be towards the centre of mass of whichever planet it's on, in this case Earth. So a cannonball is fired horizontally off a high mountain, and it would follow this trajectory. Now let's imagine that if we fired that cannonball at a greater velocity, the range, the horizontal range of the parabola or the trajectory would be greater. And in fact, considering that the Earth is round and planets are roughly spherical, we could get further and further around the outside of the planet until finally coming to a rest at the surface of the planet. And this is due to the conversion of gravitational potential energy to kinetic energy, which we've learnt about in a different video. Okay, so let's consider now that we can fire the object or the cannonball at a sufficient velocity that it will actually continue travelling around the surface of the Earth and never actually get to the end of its horizontal range. I want you to note that in the case of circular motion, the force acting on the object travelling in the circular motion is always towards the centre, acting inwards. And in this case, the force that is doing that is the force of gravity. So now, we have a final idea, which is if we can increase the initial velocity, or the initial horizontal component of the object's velocity, to a certain amount, then we can actually leave that circular orbit and remove ourselves from that force of gravity pulling us towards the centre of Earth and head out at a tangent, or actually leave or escape the pull of gravity from that object. And this is what is actually called the escape velocity, and we can calculate how fast or how high that velocity needs to be in order to leave a planet, any planet. And it happens to be that the escape velocity from Earth's surface is 11.2 kilometres per second.